Okay, so it's not yet. I'll let you know when it is. So the gold group will take their test Friday. That means that blue and remote students, you don't have to Zoom in that day. There'll be nothing happening except the test. So you can just work on your review, whatever you need to work on. If you're missing things, because remember, once you take the test, I'm not going to accept any late homework or anything. So if you're missing things for Unit 2, that would be a good chance to do some back work on that Friday. On Monday, the gold students will get that chance. You kind of get a day off or a makeup day built in with this hybrid schedule. So there won't be anything new on Monday. The blue students will take the test. Now this is important because yesterday we took a quiz and not all the remote students made it there. Okay, if you're remote, you absolutely have to be there to take these assessments when they're scheduled. If not, it makes it hard to get it done at another time. Okay, so on Monday, that's the day that blue, and then the remote students, you'll Zoom in on that day and take the test. Okay, so that kind of makes sense where we're going. Yeah, okay, so now let me stop sharing that. Let me make sure I'm ready here. So I'm gonna share, let me see what's in here. I'm gonna share my screen for the notes. I just can't see it. There we are. Okay, so if you don't already have homework number 3 out, if you want to get that out, I'm just going to grab some pens and we're going to go through it.
Kenzie, you may want to go somewhere else. Well, but not with your Chromebook.
Like in that.
When it's time for your meeting, you want to go somewhere else. Okay. So this is what your checkout quiz will be on today, and then of course this stuff will be on your test as well. Starting with those if-then statements. So it says that we want to underline the hypothesis and circle the conclusion, okay? So if it is Thanksgiving, then it is November, and you can unmute yourself if you want to participate. What is the hypothesis here?
It is Thanksgiving.
It is Thanksgiving, exactly. And so I just went through and I graded your checkouts on if-then statements. And overall, they were really great. One thing I will say with the hypothesis is the if isn't technically part of the hypothesis, okay? So if and then, though that's kind of connecting hypothesis and conclusion. Those are words that kind of put it all together. But the hypothesis is just, it is Thanksgiving. And I didn't really take points off in that checkout because if you had the right hypothesis, but you threw if in front of it, but just kind of be aware, it is Thanksgiving is the hypothesis. And so then what's the conclusion?
It is November.
It is November. And again, notice I didn't include the then there. It's just, it is Thanksgiving, it is November. This is the hypothesis, that's the conclusion. I love this one. I will gain weight if I eat a whole bag of Oreos. First of all, that one's written a little bit different. It's not written as if, then. What's the hypothesis?
If I eat the whole bag of Oreos.
Yeah, it's backwards, right? So here's an if. And so the hypothesis is, I eat a whole bag of Oreos. And so I'm saying, if that happens, what then will happen?
Gain weight.
I will gain weight. Oh boy, I don't know if I should. Okay, hold on. I'm pausing. Hold on. So now for the next couple of statements, we're going to write the converse and decide if it's true or false. So on number 3, it says, if I go to UVM, then I am a college student. So what is the converse to that?
If I am a college student, then I go to UVM.
If I am a college student, then I go to UVM. Is that true or false?
False.
False.
False. Yeah, because I could go to UVM. Maybe I go to UVM, but I could be a college student and I could go to UNH. Okay, so just being a college student doesn't automatically mean that the conclusion to that is that you go to UVM. What is the, so if it is January, then it is cold outdoors. The converse to that would be if,
No, I just want someone else to do it. I already know
I
it.
know, I do too, Jaden. Come on, someone else.
If it is cold outside, then it is January.
Love it. If it is cold outdoors, then it is January. Is that true?
It's false.
False. Could be February. Could be September. It could be really a whole lot of months in Vermont, right? Okay, so not necessarily January just because it's cold outside. Okay, next one gives us two statements. So it gives us the initial statement and then the converse. So if an angle is 90 degrees, then it's a right angle. The converse would be if an angle is a right angle, then it's 90 degrees. And it says write a biconditional. So first of all, before we even do that, since you do have a checkout quiz, for these ones that are false, I could write a counter. Now a counter is a specific example. So I said counters for both of them. So my counter here didn't ask for it, but my counter could be a college student could go to UNH. Okay, there's just a counter. So specific example of a college that's not UVM, still a college student. Same idea here, a counter could be February is cold. Okay, so a specific example why it doesn't necessarily have to be January, could just because it's cold outside. Okay, that's if we have a statement, we write the converse to that statement and it's false, then I counter it. If we have a statement and it's true, and the converse of its statement is true, then I write my biconditional. And so the biconditional is where we kind of mush them together, and in the middle write if and only if. Okay, so our biconditional on 5 would be an angle is 90 degrees, and then I'd put in if and only if it is a right angle. Okay, and notice I dropped the if and the then. So if and then gets replaced with if and only if right in between the two. I could have written it the other way. I could have said an angle is a right angle if and only if it is 90 degrees, but somehow I'm connecting the two pieces, hypothesis and conclusion, with if and only if in the middle. Do we have any questions on that piece of what will be on your checkout quiz and on your test? Okay. Next piece that you will see is the segment and angle addition. So this is not segment and angle addition in proofs. This is, here's a picture, give me an equation, solve for these things. And so our equation here would be I can take this part plus this part. Okay, so I can take 5 plus 2x minus 7. This piece plus this piece is going to equal the whole segment. And so it shows me that my whole segment is x plus 6. Part plus part equals whole. And then from there, now I can solve for x. So I combine my like terms, and 2x minus 2 equals x plus 6. And maybe I subtract x. So I have x minus 2 equals 6. And I add 2, and x equals 8. Okay, but notice I'm not done here. What then does it ask me to find?
BA.
BA, and so what is BA? Well, that's one of the parts here. So BA is from B to A, or BA is 2x minus 7. Okay, BA is 2x minus 7. So to find BA, I just need to plug 8 in for x, because now I know that x is equal to 8. So 2 times 8 gives me 16 minus 7, or BA equals 9. Okay. Same idea for CA. So then it asks me to find CA. Well, CA is from here to here. And there's kind of two ways I can do that now. Like I can either take 8 and plug it in and go, okay, well, 8 plus 6. So that's going to give me 14, not 15. It's going to give me 14. And all I did there was I said x is 8, so I plugged it in. X plus 6 is 8 plus 6 gives me 14. The other thing I could have done is, like, I know BA is 9 now, so I knew I had 9 and 5. So that part plus this part has to equal this whole length anyway. Okay, so I could have done that without having to necessarily plug in for that particular example. Okay. So that's a segment addition. If we flip this homework over, it gives us an angle addition, and the angle additions are a little bit harder really just because we have to set them up ourselves. So to figure out which piece is 26x plus 6, I'm using the letters, so ESR. So I go ESR, that would be right here, is 26x plus 6. Okay, this angle right here, ESR. TSE, so T to S to E, that would be this angle here. That's 43 degrees. And then last I have TSR. So TSR is the whole angle, and that whole angle is 37x plus 5. Okay, so with the angle addition, I need to label first. Now, same as the segment, I can set up an equation where I'm saying this part, 43, plus this part, 26x plus 6, equals the whole angle, which is 37x plus 5. Okay, this part of the angle plus this part of the angle equals the whole angle. And now I have some things I can combine. So I have 26x plus 49 equals 37x plus 5. And I subtract 26x, and 49 equals 11x plus 5. And I subtract 5, and 44 equals 11x. And what does x equal?
4.
X equals 4. Now that I know what x equals, I can find some of the missing angles. So this is saying, well, what's the measure of TSR? Sometimes I almost find it easier to go back to here for this, like the written out piece. So I go, okay, well, TSR, measure of angle TSR was 37x plus 5. Now I know what x is. I know x is 4. So I can plug that in. So let's see, 37 times 4. So that's going to give me 148, I think. And then 148 plus 5 gives me 153 degrees. 153 degrees. Okay, so that means my large angle here, TSR, 37x plus 5, when I plug 4 in, that gives me my angle. Now to get ESR, there's two ways that I could do it. I can plug in, or I could subtract 43. I could subtract this piece from the larger angle and get ESR. I'd be a little scared to do that because, like, if I did this part wrong, then that's going to make that wrong by just subtracting. So I may want to go in and say, okay, ESR here is 26x plus 6, and I'm going to plug 4 in. So that's going to give me 104 plus 6, and that gives me 110. Let's do a quick check. Does that work? So if I have 110 plus 43, that's 153. That's good, okay? Meaning these two pieces add up to what I said that larger angle was anyway. Okay, so we have if-then statements, segment addition, angle addition. Then we have our proofs. So our first proof is an algebra proof. This should be a gift. So we start with our given. Step 1, can you get your, do you have your calendar open?
No.
Sorry, I have a second grader next to me who has a Zoom meeting. Give me 1 minute. If you haven't done your proof, you can go ahead and do it. Okay, so I have my given. What's my next statement going to be?
Distribution.
Well, I don't have to distribute on this one because I don't have parentheses anywhere.
I'll go get that.
No, because you have a meeting, just let it ring. I want to get my variables to one side, so it could be a couple of different.
Subtraction.
Yeah, so if you're okay, I'm going to write it like this. Negative 2x minus 7 equals 15. It's possible that your second statement looks a little different than mine, that your second statement looks like negative 7 equals 2x plus 15. That's fine. For either one of them, that's subtraction. Did you hear that landline? Anyone else have a landline at their house?
No.
No, I love having a landline. It's not a cell phone.
Hey, Miss Sawyer.
Yeah.
I actually had 4x equals 6x plus 22, and then
That's okay.
as my reason I had addition.
That would be addition, yeah. As long as you end up in the right place, I may miss, like, it's possible that when I'm grading it and I look at the reasons, I miss it because it says addition instead of subtraction, but I shouldn't. It's still fine. That's an okay.
Okay.
You'll just, like, these two steps will be backwards because now, then you'll have subtraction, right? Somewhere.
Yes.
Now I'm going to add 7. So I have negative 2x equals 22. And for that, I'm adding 7 to both sides. So that's addition. And now I'm going to divide by this negative 2, which tells me x equals negative 11. And this doesn't have a proof here. It's just kind of an equation. But ideally, we have a proof that we can kind of check it against. And we got there using division. Okay. Okay, now the tricky proof. So a geometry proof, and it's kind of fill in the blanks. Now our first one just says measure of angle 1 equals measure of angle 3. Where did that come from? Did we make it up?
It's a given.
It's the given, yeah. So our first statement, our reason here is just that that's given to us. And I'm gonna label that as I go. So it's already kind of labeled, but I just like colors. I like to see it in a different color. So I know that 1 and 3, that they're the same angle measurement. Then step 2 says reflexive property. So that's a property we learned yesterday. So reflexive property, like a reflection, something equals itself. What do you think that something is that we care about?
The measure of angle 2 equals the measure of angle 2.
Exactly. That this angle in the middle, that I can say the measure of angle 2 equals the measure of angle 2, meaning the angle 2s we talk about down here are the same angle. Now this proof's written a little funny because then what they do is they take this first equation. So remember, like if I think of a balance beam, here's my equation. If angle 2 is the same amount, then I can add the same amount to both sides of this equation and it's still equal. So what they're doing on step 3 is they're saying if this is equal to itself, then I can add that same amount to both sides in the same way that I can add 7 to both sides of this equation. Okay, so this third step is addition, where I'm saying I'm adding the same amount to both sides. That one's kind of the tricky step to get. What's happening on step 4? What is that? So it's saying 1 and 2 equals PTR and 3 and 2 equals STQ.
Is that addition again?
That's angle addition. So that
Oh.
is like what same thing that we use here, okay? That a part of an angle plus another part of an angle equals the whole angle. Part of an angle plus another part of an angle equals the whole angle. So that is angle addition. You can once the meeting starts. So the reason that it says that is because, oh look, here I have 1 and 2 and I also have it here, which means I can take this equation that I wrote and I can put PTR in on this side, measure of angle PTR, and I have 3 and 2 here and I also have 3 and 2 here, which means I can substitute in STQ on this side of the equation. So it's saying take this equation in step 3 and substitute in what those two parts add up to. So that's substitution. Okay, that's a tricky proof. So we still have a half hour. I kind of feel like I'll be able to get through the notes I need to get through anyway. Yeah, let me know if you have an issue with the password piece. Would you like to go back and do the proofs from the day that the video didn't work first? Give me like a yes if you want to, anybody. If anybody wants to, we'll do it.
Yeah.
Let's do that. I feel like it's worth doing given that we have a test coming up. So, and I didn't realize, I went back last night to check on who's watched what video or whatever. And I realized that the video with sound, it's still not loaded. I don't know, it's just stuck there, not loading. So I apologize about that. So let's go through and do these notes so that, I'm just gonna get my copy of filled in ones so that we're ready to go. So, I don't know where my copy of filled in ones are. Well, we'll make it work. So this we've talked about a little bit yesterday. These addition postulates, these again are just things that you should always be looking for, okay? Meaning that, okay, give me 1 minute, guys. Sorry.
Trying to tell you that, but my
Bummer. Most of you are here, so I feel I'm feeling okay. Feeling okay about that. Of course, right? Because it's the one set of notes I've recorded 5 times and nobody's seen. Okay.
I know.
So then from here, this is where so first let's substitute in, and then this is where we use reflexive property in our proof. So if I know AOC, right, here's my equation. If I know AOC is 1 and 2, then I can say 1 and 2 equals, and instead of BOD, I'll substitute in what BOD is equal to, which is 2 and 3. There's just substitution. And our end goal is to say 1 and 3 are equal, which we can say if we just remove 2 from both sides, if we remove the same amount from both sides. So that's where we use the reflexive property, is we're just going to say, hey, that angle 2 is the same angle 2. Okay, so angle 2 is equal to angle 2. When we write things like that, that's the reflexive property. And that helps. I mean, this is a blank proof, but a lot of the proofs on your assessments are fill in the blank. So if it's fill in the blank and it says reflexive properties already filled in, you should kind of know what the statement should look like. It should look like something equals itself, okay? And if 2 is equal to itself, then again, we can take that same amount away and we're done. We can write that 1 is equal to 3. Because we can subtract the same amount from both sides. Okay, so that kind of completes the notes number 7. Now, before you start your checkout quiz, we're actually going to do one last set of notes today. And the reason I know this is a long Zoom session, but I'm kind of pushing it, is because tomorrow I want the whole class, right? We'll have 70 minutes to review the new stuff that we're going to talk about right now, which I think is easier stuff than proofs, and review the unit review that you're going to work on today. Okay, so it gives us a whole lot of time to work through that. Okay, so we've done notes number 7. There's one set of notes beyond that. It's a single sheet of paper. It's just one piece of paper. Okay. Notes number 8, and it's angle relationships. And we may already know some of these, or it may come back to you after we get started. But I'm going to just kind of define them and give us one example. We'll do the work tomorrow on this stuff. Okay. So everyone find this, notes number 8, or a blank piece of paper. So complementary angles, anyone know what they are? They complement each other. Anyone? Complementary angles are angles that add up to 90 degrees. So two angles that equal 90 degrees. Okay, so one thing that you'll be asked to do is, for example, if I'm given an angle, I can write its complement. So if the angle is 50 degrees or if the angle is 25 degrees. So if an angle is 50 degrees, the complement to that angle would be a 40-degree angle, because a 50-degree angle and a 40-degree angle, 50 degrees, 40 degrees, adds up to a 90-degree angle. They are complements. So then what would the complementary angle be to 25?
65.
65, yep. Okay, so this angle, here's its complement, vice versa. Here's an angle, here's its complement, vice versa. So the way that we use this is in diagrams. So I'm going to give us a diagram over here. To solve for a variable. So if I have 3x plus 7, and I know that that's 11 degrees, okay, and it asks me to solve for x, okay. So given that, so we want to be able to do this, so without a diagram, just find a complement, that's not bad. Okay, also given a diagram, if I see a right angle, then I can set up equations using these are complementary angles, or I can set up an equation saying that this part, 3x plus 7, plus the other part here, 11 degrees, well, it has to add up to 90 degrees because I can see if this is a 90-degree angle, this is a 90-degree angle, it's perpendicular, okay? And then that's how I solve for x. So now I say, okay, 3x plus 18 equals 90. And I subtract 18, which gives me 72, and divide by 3, and it gives me 24. Okay, so those are the things we'll work on, and you'll see some in your review, but we'll work on tomorrow as a little bit of a longer warm-up. Okay, but given this diagram, I know things like these two angles add up to 90, I can solve. Very similar to complementary angles or supplementary angles. These are two angles that add up to 180 degrees instead of 90 degrees. So I'm just going to extend my table here. If I have the same angles, okay, so 50-degree angle, what would the supplement to my 50-degree angle be? To make it add up to 180.
130.
130. Okay, so given an angle, I should be able to find the complement or the supplement. Or given a complement, I should be able to find the original angle and then from that find the supplement. Okay, so filling in a table like this. And if I had a 25-degree angle, the supplement to a 25-degree angle would be 155. Okay, so supplementaries add up to 180 with the angle, complementaries add up to 90. I'm going to give us, again, an example of what our diagrams will look like. So supplementary angles, okay, we know right angles look like, we know what right angles look like, what 90-degree angles look like, okay, and we see the little box here. Supplementary angles, what they look like, okay, is they create a line. Okay, it's a linear angle. So any supplementary angle set creates a line. 180 degrees is a straight line, okay? So here's a diagram, and maybe it says that 5x plus 7 and 3x plus 5, okay? And so looking at this diagram, I can see this straight line here, which then helps me set up my equation to say that, okay, 5x plus 7 plus 3x plus 5 must add up to, in total, 180. Okay, I can see that straight line. Just like I can see the right angle here, we need to be able to see 180 degree angles. So then I have 8x plus 12 equals 180, and subtract 12. And 8x equals 168, and divide by 8,
21, I believe.
and x equals 21. Okay, so here's an example of a setup you may see. Here's an example of a setup you may see. Again, should feel easier than proofs, but again, we have to identify like what does the equation look like? Okay, straight lines, my equation, everything's equal to 180. Right angles, everything's equal to 90, and solve from there. One that may be new that we haven't talked about before are vertical angles. Vertical angles are congruent. And vertical angles like never go away. Like they will be with us next unit, and we see them over and over again in geometry. And so most of the time when we see them look something like this. And so vertical angles, so vertical in like on a graph, this is vertical. Doesn't necessarily mean that it's straight up and down. So vertical angles are like across from each other. And so you have this kind of X pattern. This angle and this angle would be a vertical angle pair. Okay, so they're angles that are not adjacent, meaning they're not sharing any sides. So this angle doesn't share any sides with this angle. These angles are adjacent. These angles are vertical. And so I'm going to call this, let me put in, these angles, by the way, are also vertical. Okay, they don't share any sides. They're across from each other in this diagram. So if I labeled this 1, 2, 3, 4, we know that angle 1 equals angle 3. So given that diagram, I could set this angle equal to that angle. Or I know that 2 is equal to 4, so that these are equal to each other. Okay, so where students get tripped up on the angle stuff is like, when is it equal to 90? When is it equal to 180? When are they equal to each other? Okay, well, you have to look at the diagram, right? So straight line equal to 180, right angle equal to 90. Vertical, this crisscross business, they're equal to each other. So I'm going to give us an example. There's an example. So two triangles crisscrossing. And it tells us that this is 6x minus 1. I'm not sure if I have the right number written down here, but this has 2x plus 23, I think it says. Okay, so here's an example. So this is like, I have two triangles, they're meeting here. These angles are vertical. They're not sharing any sides. So I know that 2x plus 23, that this angle is equal to 6x minus 1. Okay, vertical angles are equal to each other. And then I can solve. So maybe I subtract 2x and 23 equals 4x minus 1. Add 1. 24 equals 4x and x equals 6. Okay, so an example of what each looks like. There's some theorems about perpendicular lines down here. I'm not super worried about it. We know perpendicular lines intersect at a right angle. One other little kind of piece that I want to make sure we define on here in case you ever see the word, you like my boxing, huh? Is a linear pair, or we defined it earlier in our packet as a straight angle. Okay, that's those supplementary angles, okay, when they create a line. And so these equal 180. Okay, this angle plus this angle would have to add up to 180 degrees. Just kind of some vocab that you may see. So we have 9 minutes. We're not going to run over. Great. So today, first thing you're going to do is a checkout quiz. So you do kind of have a little bit more work today. So I'm going to cut some of it down for you right now. So listening ears. So you have a checkout quiz. Let me stop sharing this. I'll pull that up and share my other screen. Oh, hold on, I gotta change slides. Okay. So your checkout quiz used to be like a an in-class quiz, so it's gonna look very formal. Make sure you label things. If you can print it out, awesome. That's the easiest for me on my end, but if not, make sure you're just labeling things. And so you'll have to rewrite this whole thing and then underline the hypothesis and circle the conclusion and rewrite this, so on. This looks just like our review, right? Okay, so here's this, write the converse, is it true or false? Here's this, write the biconditional. Here's an algebra proof. I'm gonna give you a little freebie and I'm gonna get you started on this proof, okay, in like 1 minute. Then you have a geometry proof, and then this is the segment and angle addition, okay? So first thing I wanna do is I wanna get you started on that algebra proof, because I don't want you to get tripped up on the algebra. That's not the point here. I'm just rewriting it. Okay, so now you can see my screen again, right? So that was the equation. And so on your checkout quiz, if you just want to make a note somewhere, first we would write our given. And I'll just tell you that the next step, we'd have to get rid of this 2. So I multiply by 2 on both sides. That doesn't multiply through here. So it leaves me with 3x plus 7 on this side, and then multiplying by 2 here gives me 28. Okay, so what I did is I multiplied by 2 on both sides. You fill in what that means for filling out your proof. Okay, but then you should be able to go from there. Okay, that was, don't even remember what number it was. I can't see it now. Number 6 on your checkout quiz today. Okay. Where'd my screen go? Okay. So then for homework, to just because you have a quiz and it'll take you a little while, you have your unit review, but this is a longer unit review. Okay, so it goes back into labeling, more labeling. This is a little bit of a combination of some vocabulary. So what does midpoint mean? How do I label this? And segment addition, or an equation setup really. This is like, okay, here's an angle, but what would this whole angle equal?
180.
180. So it's not quite segment and angle addition. It's kind of using some things we now know to be able to set up an equation to find x and then find other parts. Okay, same thing here. This is using, okay, what do we now know about angles? So APC would be equal to what angle? Vertical from it, okay? On the next page, that's where it's more formal, angle and segment addition. And then we still have this stuff. It's a long review, okay? If then statements. This is using, so this conclusion justification is saying from this, what can I say and why? So it's like a little mini proof, like can I write, what would I be able to write in a proof and what would my reason be that I can say that? One algebra proof and one geometry proof. And then this is the new angle stuff on the back. So I feel like it's too much. Like, I don't want to ask you to do it all tonight. So what I will ask you to do is maybe try to get through the evens tonight. Okay, and then tomorrow in class, we will go through all of it. Does that seem fair? Okay, if we can submit the evens from this, and then tomorrow in class, we'll go through all of it. And then this basically models what your test looks like on Friday or Monday. Okay, so today, first you have a checkout quiz, and I know some of you have another class to go to. Okay, so I just want to make sure you have this down and you know what you're doing today. Checkout quiz, do it, upload it to Google Classroom. Then you have this homework. I'm going to ask you to do evens. Okay, and tomorrow, nothing new, all review. It'll all be review. A warm up about the angle stuff. We'll do all of the unit review. Okay. Sound good? Do we feel okay about that?
Yeah.
Okay. Let me see if, okay. I'm gonna let you go. Email me if you have any questions. Certainly come to the Zoom session tomorrow if you want to be able to ask questions as we go over it, but I'll also post it after class, okay? Okay, have a good day.
Too.
Bye, guys.